Last unit, unit 11, when we did the area unit. I don't know if you guys remember or not. Let me just throw up a quick example. Let's say I have two rectangles that are similar to each other. And one side is 4 and the other side, that's not a good. How about one side 7 and the other side is 4? All right, that's the side ratio, 7 to 4. If you remember, we wrote it like this. Remember this notation, S1 and S2? Okay. We said, all right, if the side ratio is 7 to 4, anybody else remember what other ratio has to be 7 to 4 from last unit? The ratio of their, Molly? Perimeters. All right. The ratio of their perimeters is also 7 to 4. How did we find the ratio of the areas, though? Because that's not 7 to 4. Good job. Good job. You square it. So it was 49 over 16 for the ratios. We're going to do the same exact thing today, except now instead of talking perimeter and area, we're going to talk, what do you think that's an abbreviation for? Surface area and the ratio of volumes and how it relates to that right there. Okay, that's what we're going to do. First thing I want to do with you is, how do I know two figures are similar? Two polyhedrons are similar, right? So I'm going to give you guys a checklist here to see similar if. Ready? And this one's kind of common sense, but I'm still going to have you write it down. They got to be the same figures. Like I can't have a cylinder similar to a cone. Get my drift there? All right, it's got to be the same figures. So that's the first thing you want to check. Am I comparing two figures that are the same? You can't do a sphere versus a cone. They're never going to be similar. And here's where the math comes in. Their sides have to be in the same ratio. Yes, exactly. So that's what we're going to test with these two sets of figures here. See if they're similar or not. So let's go to number 1. Are they the same figures? They're two rectangular prisms, so that's good. Are their sides in the same ratio? I have no idea, but you're about to help me check. 7 matches up with what in the other prism? 7 over, got my numbers already are going. (19) 7 over 4 is 7 over 4, the same ratio as, keep going, 14 over, what's the 14 match up with? 8, 4, 6, 8. Is that this? Now look, hey, if those two come out to be the same ratio, great job. You're not a winner yet. It's got to be all sides that are given in the same ratio. So 7 over 4 may be in the same ratio as 14 over 8, but it's also got to be in the same ratio as 10.5 over 17? 6. And can I just ask, what do you guys do to see if they're all in the same ratio? Okay, so you divide all of them and see if it's the same decimal. That's fine with me. I'm just checking to see how you guys figure out if fractions are in the same ratio. What are you guys noticing? They all are, right? All 3 are in the same ratio. What do you get? About 1.75? Okay, so we could say these two rectangular prisms, yes, they are similar. And then just read the directions. If so, what's the similarity ratio? That's another name for S1 over S2. And there's a lot of different answers you could give here. Just give me two sides that match up for me. Okay, so there you go. Similarity ratio, 7 over 4. If you want to give me 14 over 8, that's fine too. All right, what about these two cylinders now? Well, they're cylinders, so that they're the same figures. Are their sides in the same ratio? Give me two ratios you're going to compare right now. 17. Give me two sides that match up, or two lengths that match up.
12 and 9.
Okay, so I'm going to see if 12 over 9 is in the same ratio as, give me another one to compare to it, 12. Luke, just give me it. 14. Is it the same ratio as 9 over 5? Good. Same ratio? Yes? No? 16? Nope. So these two cylinders are not similar. Alrighty? So that's how I can test if they're similar or not. All good. All right, now let's talk about how the S1 over S2 compares to the surface areas. I think you guys could probably just teach this right now. If I know the similarity ratio, do you think, based on what we've done already in Unit 11, do you think that's in the same ratio as the surface areas? So if, for instance, number 1, 7 over 4 was the similarity ratio. Do you think their surface areas are in a ratio of 7 to 4? Surface area. No. What do you think I have to do to it? Okay, done. Done. So if you want the surface area ratio, square two of the corresponding sides. Right? Square two of the corresponding sides. Volume. Probably not equal, right? They're probably not the same. Two sides don't equal the volumes. So what do you think I'm going to have to do with the side ratio? Just like you leave your units, right? When we solve a volume question, we end up with units cubed. Yeah. All right. Questions? So square them to get the surface area, cube them to get the volume. All right, let's see on a Friday here what we got. These two cylinders are similar. I'm giving you the surface areas of each. What's the similarity ratio? Again, hey, we see similarity ratio. We're thinking S1 over S2. What's the ratio of the sides? Oh, how do I do? Wait. I am giving you the surface area. Giving you the surface area, but now I want the sides. So I wouldn't square them, though, because that's too much. So if I have 49 over 81, how do I get to the similarity ratio? All right, because to go this way to the left, I would square it. So what do I want to do with 49 and 81 then? There you go. Take the square root. Don't start with me. And it ends up being 7 over 9. That's the side ratio. Yep, 7 to 9. All right, you're tough stuff there, but what if I give you the volumes now? If I give you the volume, 125 over 512, how do I get to similarity now? Well, don't say cube it. Cube it means raise it to the third, which is what I would do if I was going this way to the left. Cube, root it. Yes, which I showed you guys yesterday, but you knew already, I guess. I don't remember when we did it, but you say we did, fine. I'm not going to argue. Memory is not like what it used to be. Cube root of 125, 5 over, what was 512, 8? So 5 over 8 is my similarity ratio. Good. So you picked up on that pretty well. Let's see what you got. This is going to separate the studs from, I don't know what it would be on the other end. All right. So I'll let you read through it. So just to give you a visual, all right, please don't draw this out, but just to give you a visual of what's going on here. Say I have two cylinders that are similar to each other. Here's what this problem is saying. The surface area of the smaller one is 75. Surface area of the bigger one, 108. And the volume of the larger is given. So the volume of the larger is 216. What's the volume of the smaller? Now, I just drew a cylinder. We have no idea what this figure is, so I can't use a volume formula. All right? But what I'm going to need is, what am I asking you to find? Surface area or volume here? Volume. So what you can do to help me is find out what ratio the volumes are in. You need V1 over V2. I need to, if you're, okay, you're going to have me find the volume? Sure. Give me what the ratio is of the volumes then. What ratio do you already know? What ratio did I give you? Surface area. So let me go to a blank page here. So here's what I'm asking from you guys, and maybe you can figure out a way. I'm giving you this, right? You know what to plug in for here because I gave you both. I need that. But I never gave you anything on today's, right? How surface area and volume relate. I never gave you anything. But can you still get there? Can you still get there for me? If you know the surface area, how can I get to the volumes? Okay. What can you get to if I give you this? You can get to what? Right? You can get to this, can't you? And if I give you this, can you get to volume? All right, so there's our answer. Find the similarity, and then we'll do something to it to get to the volume. So that's our plan. Good talk here. All right, so here we go. 75 over 108 is my surface area ratio. You guys said I can get to S1 over S2. How? Square root both sides. So when your calculator right now, and I got mine up here, I'll do it with you. Let's get a fraction template up. Square root of 75 over square root of buck 8. 5 over 6. Nice. 5 over 6. All right, what do I do now to get to the volume? What do I do to get to the volume now? With the 5 and the 6, what do I need to do? Cube them to get to the volume. So what is the volume ratio? 125 over 200 and. See how we found the volume ratio? Yes, we good? I went through the similarity one first. Now, find other volume now. Find the answer. Find what we were looking for. Ready? I know the volume ratio is 125 over 216. There's V1 over V2. Equals, what volume do we know? Is that of the larger or the smaller? Larger, so it should go across from the larger one. And I know this isn't the best of ones because they end up being the same. And then I'm looking for the volume of the smaller one. And it comes out to be 125. What's my units here? Any of the units? Centimeters cubed. Don't find the volume unless you know the volume ratio. Go ahead. You guys are on number 6 now. Try out number 6. Same question. So find the volume ratio first. Find V1 over V2 and then set up a proportion. Side ratio is 4 to 5, but I need the volume ratio, so I cube them. 64 over 125. All right, so that's the ratio you use when you write your proportion now. 64 over 125. Where'd you put the 500 now? Across from 125 because it was the bigger one. Solve for x. What did a little help here? 256. We're solving for volume, cubic inches. Okay. If they're asking you for a volume, find the volume ratio. If they're asking you for surface area, find the surface area ratio. Plenty of time to get this done. Show your work. Check your answers, please. Call me over if there's any concerns. Big 2 days next week. Tuesday and Wednesday next week are some of the tougher ones we've done in a while to end the year and end this unit.